turbine?
Yes, sir.
Yeah. This is called a Pelton turbine or a Pelton wheel. And it consists of important parts like the runner. The runner is a disc. On this disc, the hemispherical vanes will be connected. These are called as buckets. On these only the jet will be impacting so that it will start to rotate. And another one is called as important part of the casing. The casing is made out of a cast iron. The casing is made out of a cast iron. It will become an enclosure. So in this enclosure, the turbine will be rotating, which will avoid the splashing of water here and there. Okay. And this is called as the nozzle. The nozzle will be connected to the penstoke. Penstoke is one pipe which will be flowing from the reservoir. Already we know that in the previous classes. And this is called a spear. And this spear is governed by certain automatic devices. Actually, this you can able to see in our practical classes also. I can show you. And based on the requirement, the spear can be moved front and back so that the cross section of the nozzle through this the water will be flowing can be varied. So we can able to adjust the flow of water smoothly. It will flow into this. And after this will be a jet of water, and this will be a penstoke. A penstoke is one which will be opened, and at this particular point what happens at low velocity after performing the function on these vanes, it will be flowing into the river. Okay, this is how the different parts. Okay, and this I have shown. You can see here, you can able to see the simulation. The water it is flowing from the penstoke, and it is a spear which is governed by certain systems, okay, based on the requirement, and the water will be moving onto these vanes. The vanes, as I told you, it is bucket-like structures, hemispherical buckets. Those will be fixed onto the circumference of this rotor. Okay, this is how the construction is made, and this is called braking jet. And whenever you want to stop the movement of the blades for certain program, or suddenly you want to stop down, as I told you, the speed will be more than 30,000 RPM. It is not possible to stop down by cutting down the flow of water through the nozzle. What we have to do, we have to use a braking nozzle. The braking nozzle, what it will do, it will flow the water in the opposite direction. You can see that here the water is flowing, it is rotating like this. And if the water is flowing like this, what happens? It will flow in this opposite direction. So it will avoid the rotation of this one. And this is what the construction of the Pelton turbine. The Pelton turbine, the main important parts: rotor, a shaft, and the buckets or the vanes, and the casing, and the nozzle. Okay, these are the important parts of the turbine. This turbine. This is what I have explained here. The casing, a spear, runner or a rotor, and the penstoke. Penstoke I have not shown here. A penstoke is open. You can see here. This will be called as a penstoke. So water after performing it is impinging on the buckets, which will be flowing down, which will be flow through this penstoke. Okay, at the low velocity. At low velocity, it will be flowing out. Okay. And now let me try to see the working of this Pelton turbine. How the Pelton turbine will be working, we'll try to see this. So already I told you in the reservoir, there will be a head of water. If the increase in the head of water, the pressure will be more. Hydrostatic force will be more. Okay, the hydrostatic force. So what happens while it is going through this penstoke, the kinetic energy of the water will be more. And when it is passing through the spear or the governed spear, here there is a nozzle. While it is flowing through the nozzle, what happens? The pressure will drop down, the velocity will increase. Here the pressure was more, and the pressure will drop down, the velocity will be increased. So due to increase in the velocity, what happens? It will be striking over the blades, series of blades. And this will happen instantly, very instantly it will be happening. Once it is imparting the force onto the turbine, the resultant force acting on these vanes will cause the vanes to move. As because of the vanes will be connected to the rotor, in turn it will be connected to the shaft will start to rotate. The shaft already you know that it will be coupled to the generator. The generator will be developing the alternating current. This is how we get the output as the electric out energy. The hydraulic energy will be converted into electrical energy. Once again, I will be explaining it. The water which is available in the reservoir, which will be having a lot of potential energy. While it is flowing through this pipe, what these pipes are called? What is the name of this pipe? Anyone? Just now I shown. Okay, penstoke. It is called as a penstoke. When it is flowing through the penstoke, it will be having the high pressure and low velocity. And when it is passing over the nozzle, what happens? The velocity will increase and the pressure will drop down to the atmosphere. So at this high velocity, the resultant force acting on these vanes by means of a jet of water, which will causes the vanes to rotate. Since these vanes are connected, are coupled, are assembled to the rotor of the turbine, what happens? The turbine also will rotate. You can see that the turbine vane, and this is a turbine rotor, and this turbine rotor will be connected to the shaft, and output of the shaft will be mechanical output. This will be coupled to the AC, the generator, which will be developing the alternating current. This is how the Pelton turbine or Pelton wheel will be working. Okay, we understood the Pelton turbine. This is what I have written here. Now, let me try to understand the Kaplan turbine. The Kaplan turbine, it looks very simple. You can see here, the positioning of this Kaplan turbine will be vertical. In the previous case, you can see that it was horizontal. The shaft will be parallel to the earth, and here the shaft will be perpendicular to the earth. That is perpendicular to the ground. So it will be in